In this lesson, we would understand the applications of lines and planes in vectors. The learning goals of this lesson are to determine the point of intersection of lines and planes. Second is to determine the shortest distance from a point to the given lines. Definitely we will be given the line equations for this. After the students go through the lessons, the students will be able to determine the point of intersection of a plane and a line given their equations. Second is the students will be able to determine the point of intersection of three planes given their Cartesian equations. Third is that the students will be able to use substitution for determining the point of intersection. So the technique that will be used will be substitution. And last is that the students will be able to apply the formula that will be given to determine the shortest distance from a given point to the line in 2 space and 3 space. Let's understand all this with example questions. So the first type of question is to determine the point of intersection between line and a plane when we are given the equations as for line the equation is given in vector form. So it's vector equation r equal to 3, -2, 1, and the direction vector for this is s 14, -5, -3. The plane equation is given to us as in Cartesian form, and that is x plus y plus 3z minus 4 is 0. Any calculations for line or plane equations that are given in vector form, the best way is to first change it to parametric form. So we will change this line equation in parametric form. So it would be x equal to 3 plus 14s, y equal to -2 minus 5s, and z equal to 1 minus 3s. All we would have to do is we will call this plane equation as equation number 1. And we would start by substituting this above x, y, and z equations of the line in equation number 1, that is the equation of the plane. So x will be replaced with 3 plus 14s, y will be replaced with -2 minus 5s, z will be replaced as 1 minus 3s, minus 4 is 0. We will simplify this and collect the like terms. So 3 minus 2, for that we would just expand this first and we would have 3 plus 14s minus 2 minus 5s plus 3 minus 9s minus 4 is 0. When we collect the like terms, we get 3 minus 2 is 1 plus 3 is 4, minus 4 gives us a 0. 14s minus 5s gives us a 9s, minus 9s gives us a 0s is equal to 0. When we solve for s, we get s equal to 0. Now here this s is not any random variable. This s stands for the constant of the direction vector. So if s is 0, that means there is no direction vector. So the line that has no direction vector and just an initial point, and from that point we can draw infinite number of direction vectors. Therefore, we would conclude from here that if s value is obtained as 0, we would have infinite solutions. If s value comes out to some infinite number, we would conclude that we would have no solution. And if s value comes to be any constant, does not matter what, we would only have one solution. And to get that one solution, we would just sub in that s value that we get here. So for example, if we get s as 2, we would just sub in s as 2. We would just sub in that s value in this x, y, and z, and that would give us the x, y, and z coordinates of the point of intersection. Now, let's conclude what is the solution for this problem, or what is the point of intersection. Since we've got s as 0 and we have infinite solutions, we can get those infinite solutions by subbing in s as any number of our choice. So what we do is, to conclude, we can just put in s as whatever we feel like, but it has to be the same s value at all 3 coordinates. So it's going to be 3 plus, let's say we use s as -1. So it will be 3 minus 14, which is -11. That will be the x value. Y would be -2 minus 5. S is -1. That would give us -2 plus 5, which is a 3. And this would give us z equal to 1 minus 3 times -1, which is 1 plus 3 is 4. So the point of intersection that we finally obtain in this particular case is -11, 3, 4. And this is how we get the solution for this problem. Let's move on to the next type of problem where we have to find the point of intersection between three planes. To determine the point of intersection between three planes, we will be given the plane equations in Cartesian form. So let's say we have the equations as x minus y plus z is equal to -2. We call this equation number 1. The second equation we would have is 2x minus y minus 2z is equal to -9. That is called equation number 2. And the third is 3x plus y minus z is equal to -2. That's called equation number 3. All we have to do is just solve for x, y, and z. That is the common coordinate between the three equations. We need to solve for three variables and we have three equations, so we would just use substitution here. To begin with, we will solve the first equation for any one of the variable. I'm solving for x. So I would have x equal to -2, which is this, plus y, because -y moves on the other side, minus z, that comes from here, plus z goes on the other side, becomes a minus z. And we call this equation number 4. Now all we have to do is just sub in this equation number 4 in both second and the third equation for x, such that we have equation 2 and 3 in the form of y and z only. So we would do so, substitute 4 in 2 and 3 in place of x. So we have x as -2 plus y minus z minus y minus 2z is -9. Just simplify it by expanding. So -4 plus 2y minus 2z minus y minus 2z is -9. Minus 2z minus 2z gives us a -4z. Plus 2y minus y gives us a y. Minus 4 is just -4 is -9. We can move this over and it would give us y minus 4z is -9 plus 4, which is nothing but a -5. So we get this equation, and let's call this equation number 5. Similarly, we'll substitute 4 in 3 as well. So here we're just substituting 4 in 2. In place of x, we put in -2 plus y minus z plus y minus z is -2. Expand this further as well, and we get -6. 3 times y is 3y. 3 times minus z is -3z plus y minus z is -2. When we collect the like terms, 3y plus y gives us 4y. Minus 3z minus z gives us a -4z. And this -6 is equal to -2. When we move this over, we get 4y minus 4z equal to -2 plus 6, which is a +4. We can divide all three with 4, such that we have y minus z is 1. Let's call this number 6 equation. To solve this further, we use this, and we can do elimination. So y minus 4z is -5. Here y minus z is 1. For eliminating, we can subtract the second equation from the first equation. So this gets cancelled. We have -4z plus z is -3z. And we have -5 minus 1 is a -6. When we solve this, we get z is -6 divided by -3, which is a 2. Similarly, we can solve for y by subbing this z value into either this or this equation. let's say we put it here. So we would have y minus, in place of z we put a 2 now, is 1. So we would have y is equal to 1 plus 2, which is a 3. Once we have y and z coordinates, all we have to do is just pick any one of the first, second, and third equation, sub in y and z in there, and solve for x. We also noticed that we had isolated for x here, so we would use the y value as 3 in here, z value as 2 in here, and solve this to get the value of x. And we can do that here. So x is negative 2 plus 3 minus 2. This gives us minus 4 plus 3 equal to x. So x is basically minus 4 plus 3 is a minus 1. Writing all of this together will give us the point of intersection. So we would say point of intersection is x, y, and z, where x is minus 1, y is 3, and z is 2. And this is our solution for this problem. Next, we have to determine the distance from a point for which we will be given the coordinates to a line. The line could be in 2 space or 3 space. This is very simple because for this we just have to know the formula. And the distance formula for line in 2 space is ax naught plus by naught plus c magnitude, the whole thing divided by root a square plus b square. Similarly, we have a formula for line in 3 space. The only difference is that we add another constant there. So it's ax naught plus by naught plus cz naught plus d, the whole thing divided by square root of a square plus b square plus c square. Make sure we take the magnitude of the numerator, means only the positive value. Let's do one example so that we understand how to apply the formula. Let's say we are given a point P and the coordinates are negative 6, 4. Because it's only x and y, so we will be applying the r square formula. So this is for 2 space and this is for 3 space. And we will be given the line equation, which in this case is 5x minus 3y plus 15 is 0. So this is what represents A, B, and C. So A, B, and C represents the constants of the scalar equation or Cartesian equation. Now how do we put all this in the formula is, we know distance formula is ax naught. So it's technically just a product between a and x of the point. So a is 5, x of the point coordinate is negative 6, plus b is minus 3, y is 4, plus c is 15. No matter what we get in the numerator, we have to take its positive value. So that's why we put this mode sign. The whole thing divided by square root of a square, which is 5 square, plus minus 3 square, which is b square. When we solve this, we get 5 times minus 6 is negative 30. 3 times 4 with a negative sign is a minus 12, plus 15. Mode of this, the whole thing divided by square root 25 plus 9. This would give us minus 27 mode over square root 34, which will be equal to 27 over square root 34. When we put this on the calculator, we get 4.63, and this will be the distance between the given point and the line. We can write this answer as 4.6 units because we don't know what units this distance is in. And this is how we solve for the distance. If in case we're given a line in 3 space, the only thing we would do is, because we would have 3 coordinates, so we would just use those 3 coordinates, and the line would also have 3 constants a, b, and c. So we just reapply the formula with introducing z as well as an extra constant in there. And the rest of the procedure is all the same.